probability problem from 2014, paper 2. This one's not too hard. It's a little tricky if you don't read it carefully, but we're going to start with the fact that there is a bag containing 1 green and 2 red. So I'm going to write that up here. The probability of pulling out a green is going to be 1/3, and the probability of pulling out a red is going to be 2/3. 2 players, Ava and Barry. Ava goes first, it says. And the first question, well, she wins if she selects a green. And Barry wins if he selects the red. So what's the probability that Ava wins on her first turn? Well, she goes first, so she's going to win if she pulls the green. So the probability of her winning on her first turn is the probability of pulling the green, which is 1/3. And that is done. The probability Barry wins on his first turn, well, in that case, 2 things really have to happen. Ava would not win on her first draw since she goes first, and which means to multiply. There's a dot for multiplication. So Ava not pulling out what she wants, and Barry getting the red. So I'll put Barry yes. So the probability that Ava does not pull out a green is 2/3. And then the probability that Barry pulls out, let's see, they replace it each time, so replacement. So that Barry does pull it out is also 2/3 since we put it back in. So Ava not pulling out a green is 2/3. Barry pulling out a red is 2/3. So the probability he wins on the first play is 4/9. Okay, this next part is, I think, a little bit trickier. Ava wins in one of her first 3 turns. Well, the first term, one of the first 3, so let's take one turn at a time. So Ava win, that's the first one. I'll put first here. So we already know that that's 1/3. Or plus the second turn, in order for that to happen, Ava would not win. Ava no on her first one. In order to get to the second term, Barry would be no on his first one, and Ava would be yes on this second one. So in order to get to that second term, they both have to lose on the first. So Ava no, Barry no, and then on this term, Ava yes. So Ava no is 2/3, Barry no is 1/3, and Ava yes on this turn is 1/3. Okay, we'll get all that calculation in a minute. Now the third term, so one of her first 3 turns, last one. So in order to get there, she would be no on her first, and Barry would be no on his first, and multiply. Ava would be no on her second, and Barry would be no on his second. And then finally, for her to win on this term, Ava would be yes on her third turn. So Ava no is 1/3. No, that's 2/3. 2/3. Ava no on her first term is 2/3. Barry no is 1/3. Ava no on her second term is 2/3. Barry no is 1/3. And then Ava yes on her last turn, there's 1/3. 1 green out of 3 marbles. Well, there's all the numbers if we can calculate that. So we have 1/3. And it's calculator friendly, so 2 9/27, and then 2 times 2 is 481st. 3, no, that's 404 over 243. There's 5 3s in the denominators. It's time to go to the calculator. Punch, punch, punch. 0.424. Now, the fact that Ava eventually wins, and this thing could go on forever. But if you look at the last problem, check out those probabilities, and you might notice a pattern. And that pattern is those probabilities of each successive term is a geometric sequence where R is, you're multiplying as you go up the line here, you're multiplying by 2/9. So let me write R equals 2/9. So if she eventually wins, it's going to be first, second, or third, or fourth, or fifth, or... So what that's going to be is the sum of that infinite series, the probability that she wins eventually. So the sum of an infinite series, if you remember, is the first term, which is 1/3, over 1 minus the ratio of 2/9. So the probability that she eventually wins is either on the first term or the second term. That's why we're adding these. Or the third term, or the fourth term, or the fifth, etc. So it's an infinite series, and that's 1/3 over 7/9, which is 1/3 times 9/7, which equals 3/7. And there's your answer. Or you could write that as a decimal, 0.429. So that last one is a little tricky, but it makes sense, I think. And that, I believe, is the end of number 12. Yes, it is.